Hello, dear students. Welcome to Physics Plus Maths with Dr. Sajuket on YouTube channel. This is the second lecture of Class 12 Physics. In the last class or in the previous class, we discussed some topics like what is electrostatics and what are the methods used to charge a body. Okay, in this lecture, we will discuss mainly two topics: induction and gold leaf electroscope. Actually, in the last class we studied there are three methods to charge a body. First one is rubbing, or it is also called friction electricity. The second method is conduction. Those two methods we already discussed in the last class. Okay, so in this class we are discussing the third method, which is the induction. Okay, so what is meant by charging by induction? I will explain that what is meant by charging by induction. Suppose you have a conductor, you have a conducting material, and usually it is placed over an insulator, so that if it is charged, the charges will not flow to earth. That is why it is placed over an insulator. So our conductor, this is our conductor, let it be a copper ball or anything. It should be a metal, it should be a conductor, it's a conducting material. Okay, so this conductor, suppose we bring a charged body very near to this conductor. We bring a charged body, suppose it is a positively charged body, we are bringing the body very near to the conductor, but we are not touching the conductor. Okay, we brought the conductor, this is the conductor, charged conductor or charged body. It can be charged conductor or insulator. The one thing which is important is it should have some charged material. We are bringing the charger, we bring the charged material very close to the conductor, but we are not touching the material. Okay, so this material, there is a small gap, so the charged body is very near to the conductor but not touching. Okay, then what happens is that because of the effect of this charge, this is a conductor, so the electrons inside the conductor, they will move towards the positive charge. Okay, you can simply imagine, because electrons are free inside the conductor, they can move anywhere inside the conductor, so they will move towards the positive charge. So when the electrons move from this side, there will be a deficiency of the electrons. It is said to be a positive charge. Okay, that means what is meant by positive charge in the conductor? The electrons, when the electrons move to one side, there will be an imbalance in the distribution of electrons. Okay, so we say there is a positive charge on the other end. So the two types of charge, now what happens, because of the presence of this conducting material, a redistribution of charges takes place inside this conductor. Okay, this is due to induction, this process is called induction. Okay, but if you remove this material, what happens? The charges will be, the electrons and the electrons will come to the place where there is positive charges, so charges will be neutralized, and the body, this conducting body, will go to the original state, which is a neutral state. Okay, so what can we do to maintain the charge on this conducting body? One thing we can do is that we can connect this conductor, this part, like we can connect this positive charger part to earth. Then what will happen? The positive charges will flow to earth. Then all the positive charges are removed, and now there is only negative charge on this body. Then it's fine, the body. Yeah, I'm drawing the same body, which is supported by the insulator. Only negative charges, the charges will be uniformly distributed in the body. Positive charges flows to earth. Actually, when we say positive charges flows to earth, there is a problem, because positive charges will not flow. in a conductor, positive charges cannot flow. Actually, the electrons are flowing. So what happens is that electrons which come from the earth, they neutralize these positive charges. That is what actually happens here. Okay, electrons coming from the earth, they neutralize these positive charges. Okay, so uh, we have to consider earth as an electron bank. Earth is an electron bank. Electron bank. What is the meaning of electron bank? You know what is the meaning of bank? Normally banks deal with money. Okay, uh, they will give loans to you. Otherwise, you can deposit money in the bank. Similarly, uh, earth earth is an electron bank. By the word earth is an electron bank, I mean that earth can donate electrons as well as it can receive electrons. Okay, so the positive charges close to earth means electrons which come from the earth neutralize the positive charges. Okay, so this is charging by induction. When a charged body is brought near to an uncharged conductor, this is the uncharged conductor, this is the charged body. When a charged body is brought near to an uncharged conductor and placed without touching, okay, notice the point, placed without touching. We studied the case of conduction. In conduction, the charged body touches with the conductor, uncharged conductor. Then the charges flows to the body. Here, in induction, there is no touching. Okay, so the charged body is brought near, but it is not touched with the uncharged one. Okay, then the charges, the redistribution of charges takes place. Actually, no new charges comes to this conductor. You can see that only a rearrangement of charges inside the body takes place. No new charges enter the conductor. Okay, so if you have two bodies, it is easier to charge the bodies. In this case, this is a case of induction. In this case, it is easy to charge the body. The two bodies are these two conductors, both are conductors. Okay, these two are conductors. They're placed over insulators. You know why they are placed over insulators. Insulators are used to keep the charge on the body. Otherwise, the charges will flow to earth. Okay, so here a charged body is brought near to the ball A or a sphere A or conductor A, but it is not touched. It is brought very close to the A. Then what happens? Actually, A and B are touching each other. They are conductors. Electrons can easily flow from one body to another. So electrons will flow to the side. Okay, so there is a deficiency of electrons on the other side, which constitute a positive charges on the other side. So charges are redistributed or charges are separated by the presence of this charged body. Okay, so if you separate A and B, here in the figure C, what is shown is we have separated the two spheres. Then what will happen? When we have separated the spheres, what will happen? The two spheres are separated, but the charges are there. The negative charge is on A and positive charges are on B. Then we can separate, then we can remove the charge body. Before that, you cannot remove the charged body. If they are touched each other, kept touched each other, and you remove the charged body, what will happen? All the charges will neutralize each other. So first you have to separate the two bodies, then you can remove the charged one. Here there is no charged one. Okay, so the charges will be attracted and they will come into this fashion. Okay, if the bodies are more separated like this, the charges will be uniformly distributed in those bodies. Okay, now we got two charged bodies. One is negative, A is negatively charged and B is negatively charged. Okay, this is how we can charge bodies using the process of induction. So what is induction? If you need a definition, you can write this definition. When a charged body is brought near to an uncharged conductor without touch and placed without touching, that end of the charged conductor which is near to the charged body gets oppositely charged and the farther end is charged with the same type of charge. I think you got the sentence. The end of the conductor gets the opposite charge. This is a positive charge. When it is brought near to uh, this conductor or this system, what happens? This end becomes oppositely charged and the other end becomes uh, same similar charge. Okay, so the nearer end becomes opposite, gets in opposite charge, and the farther end gets the same charge. Okay, now we are going to the electroscope. What is an electroscope? It is a device used to detect the presence of electric charge. We cannot exactly measure how much coulomb it is. You know what is coulomb? Coulomb is the SI unit of charge. SI unit of charge is coulomb. We will explain it later. SI unit of charge is coulomb. So, what is electroscope? It is a device used to detect the presence of electric charge. It cannot be used to get exact measurement of charge, but we can detect the charge on a body. So, how can we measure the charge on a body? This is setup, electroscope setup. There is a glass box. This is a glass box, so that you can see the this gold leaves. These are gold leaves, and two very thin gold leaves. Why gold is used? One reason is it is a metal. The second reason is gold has highest malleability. What is meant by malleability? Malleability is an important property of metals. They can be made into thin sheets. That property is known as malleability. You may have studied one more property of metals. It is ductility. Metals can be drawn into thin wires. Okay, malleability is highest for gold, and ductility is highest for which metal? Platinum, right? Platinum has highest ductility, gold has highest malleability. So we are using gold. Okay, gold is a very good conductor as well as it has highest malleability. So thin sheets of gold can be made. That is why we are called gold leaves. Leaf means very thin. Okay, or gold foil. Okay, that means it's very thin. So two gold foils are there. When there is no charge there, they will be touching each other. When we apply some charge, what happens on this knob? They will be separated. The gold leaves will be separated because of the repulsion of the charges. Electroscope can work on two methods: conduction and induction. We have studied there are three methods. There are two methods to charge a conductor. Okay, conductors can be charged using two methods. Which are the conduction and induction. Okay, electroscope can work on the two methods. One is conduction. Suppose you bring a positively charged body and uh, made into touch with this knob of the electroscope. Okay, this knob. Okay, you are bringing a positively charged body and it touches with the knob. What happens? The charges will float into this, and finally it will float to this gold leaves, and both the leaves will get like charges. I mean positive charges. Then they will be separated. That is what's shown here. Okay, when positive charges, this positively charged body touch this metal knob, the charges will flow down, and the two leaves will get positive charges. Because of the repulsion of like charges, they will separate each other. The degree of divergence of the leaves gives a rough measure of the amount of charge. If the leaves are more separated, we can say this body is more charged. If the leaves are less separated, we can say the body has a small amount of charge. Okay, the electroscope can also work on the principle of induction. How is that? You are bringing the charged body close to this metal knob, but it is not touched. This charged body is brought very near to the metal knob, but it is not touched. Then induction will work. You know what is induction now? Okay, when the positive charged body is brought near, opposite charges will be induced here. I mean negative charges will be induced in the metal knob. Okay, and on the other end positive charges will be induced. Okay, if you consider the entire setup, this rod and the leaves as a system, at one end negative charges are induced and the other end positive charges are induced. Here also positive charges are induced on the leaves and the leaves will be separated. Okay, similarly you can bring negative charges and the leaves will get negative charges, they will be separated. Okay, so you will get an idea about the charge of the body. You can detect the charge, you cannot exactly measure the charge, or you can say that anyway you can say that the degree of divergence gives a rough measure of the amount of charge on the bodies. Okay, so what is a gold leaf electroscope? It is used to measure to detect the presence of charge on a body. Okay, it works on mainly the main component of it is the main part of it is the gold leaves which separate when charges flows to it. Okay, it's a simple setup. Now the question, state whether, now we have studied about induction. When a charged body is brought near to an uncharged body, what happens? Uncharged conductor, what happens? Charges are induced or charges are redistributed on the conductor. Okay, state whether the following statement is true or false. It's a very important question related to induction. During charging by induction, new charges are created in the body. State whether this statement is true or false. During charging, new charges are created in the body. Is the statement correct or not? Actually, this statement is wrong or it is false. Why? When we charge a body due to induction, the charges do not flow to this conductor. What happens is that this a conductor means it has a lot of free electrons. The free electrons will be rearranged. The free electrons come to the side of this charge and the positive charges comes at they move to the other end. You can say they move to the opposite ends. So what happens is that no new charge has come to this body, but only a redistribution of charge takes place. So in induction, no new charges are created in the body, only a redistribution of charges takes place. I think it is clear to you. Okay, so during induction, only a rearrangement of charges takes place, no new charges are created in the body. This is the answer of the question. Now uh, I'm going to discuss one more important question in this topic. Repulsion is a sure test of electrification. Explain. Okay, repulsion is a sure test of electrification. What is the meaning of this question? Electrification means getting charged. Magnetic okay, magnification becomes not magnification. When a body there is similar question magnetism that is like this. uh, the repulsion is a sure test of magnetism. Magnetism, explain. Okay, it's a similar question, magnetism. We will discuss it in the topic of magnetism. Okay, so here the question is that repulsion is the sure test of electrification. Explain. That means uh, a positively charged body can attract a negatively charged body, right? Yes, a positively charged body can attract a paper bit also. You know, a paper bit. You're rubbing your pen with your hair and you're bringing that pen near to some paper bits. They will be they will get attracted, they will get stick on it. Okay, so what is the reason? Is the paper do you have charged that paper bits? No, the paper bits do not have any charge. Then how can this charged body attract the paper bits? It's another phenomena called polarization. Polarization. Okay, that we will study in the next chapter. Okay, the charges of this, actually paper is an insulator. or we call it as it dielectric. Okay, dielectric, we will mention those words in the next chapter. Okay, and some charge separation will takes place in this body. Charge separation like induction, it is like induction, but it is called polarization. And this uncharged, actually paper bit is uncharged, but due to the presence of this body some polarization takes place, and this positively charged body can attract this uncharged paper bit. Now you just forget about the process which is taking place inside the paper bit, but you can say that this is a neutral paper bit, and it is attracted by this positively charged body. So a positively charged body attract a negatively charged body as well as a neutral body. So when a body when a body got attracted by a positive charge, you cannot say that this body is charged. Okay, I think it is clear to you. A positive charge can attract a negative, an opposite charge as well as a neutral body. That is example of paper bit. Okay, it's a neutral body, but a positive charged body or negatively charged body can attract those paper bits. Not only the positive charged body, but also the negatively charged bodies can attract paper bits. So a charged body can attract oppositely charged body as well as neutral bodies, but a charged body can repel only positively charged bodies. A charged body can repel only positively, the only similar charged bodies. Okay, a charged body cannot repel neutral bodies. So we can say that attraction is not the sure test of electrification, but repulsion is. Okay, attraction is not the sure test of electrification, but repulsion is the sure test of electrification. Why? What is the reason? A charged body can attract another oppositely charged body as well as an uncharged body. I think it is clear to you. But a charged body can repel only similar charged body. The case is similar in the case of magnetism. In the case of magnetism, uh, suppose a magnet, I will explain that. The south pole of a magnet can repel only the south pole of another magnet. Okay, it will be repelled because the south pole and the south pole comes together, it will be repelled. But the south pole can attract another north pole as well as an uncharged body. Sorry, not uncharged, another magnetic material like iron. It is not a magnet, but it is a magnetic material. Okay, so a magnet can repel only another magnet, but it can attract another magnet as well as a magnetic material like iron, nickel, cobalt, etc. So when a magnet attracts a body, you cannot say that it also is another magnet, but you can say that when a magnet can attract another opposite pole as well as a magnetic material, but it can repel only opposite poles. So when we go to the magnetism, we can say that magnetism, repulsion is a sure test of magnetism also. Here we study repulsion is a sure test of electrification. In magnetism, we can say that repulsion is a sure test of magnetism. So in this video, we studied about induction. What is induction? You got the definition. When a charged body is brought near to an uncharged body and placed without touching, what happens? The when the second body should be a conductor. That is must. When a charged body is brought near to an uncharged conductor, what happens? The charges are redistributed in the conductor and it gets charged. Okay, the near end gets oppositely charged and the farther end gets a similar charge. Okay, that is induction, as I have explained this. opposite charges are induced in the body. If we can remove any one of the charges, the body will be charged. If you are not removing the charge, when this charged body is removed, it's moved away, what happens? They will neutralize each other. So we studied, it is easy to charge two bodies keeping together like this, spheres A and B. Okay, then we discuss the case of what? Electroscope. What is electroscope? It is a device used to detect the uh, presence of charge on a body. When the leaves are more diverged, we can say that there is more charge on these leaves, I mean gold leaves. Okay, you understood why gold leaves are used in electroscope, because of its high malleability and conductivity. Okay, so this end. Okay, uh, so you understood the concept of induction and electroscope. We will move to the other concepts in the next video. Thanks for watching.